Hello viewers, in this session I would like to discuss on elongation of uniform rectangular taper bar under uniaxial load. Means the load is acting on either side of the faces. In this rectangular taper bar I have considered a width of at bigger end is A and width at smaller end as B, and the load applied on either end is P, right, and the total length of the bar is L, and the Young's modulus of the material is E, and thickness of the material I have considered as T. Some nomenclature I have taken for the understanding of the rectangular bar under axial load. So now what I do, I will consider the section, consider a section XX at a distance of X from the bigger end, that is face A, right, that is face A of the rectangular bar. As you can see, this is the distance which is taken as a X to consider a element. So I need to know what is the width of this section. Considered section is XX, so width of the section. So width of the section XX is, so what I can write? So I can write the maximum dimension or width is A. So in this what I do, I will take the average of A minus B times X for the length L. So as it is been considered similar for circular tapered bar. So here and for the simplification purpose I will write A minus K times X. K refers to here A minus B by L. So this part I have written as a K, and that is the width of the section at the section XX. So now once I know the width, I need thickness of this one and I need the area of this one, because I wanted to calculate the total stress and the total elongation of the strip. Later, once I get the total elongation of the strip, later I will take it to whole body from 0 to L. So for that now I will consider thickness of the section XX. Thickness of the section XX, it is nothing but T. That is what it is similar throughout the length. The thickness is similar, the width is different. So now area of the section. So area of the section. So area of the section. So how I can write? I can write width into thickness. So width is A minus K times X times T. That is the section area of the section A minus Kx times T. So once I know the area, now I need to concentrate on the stress part. So therefore stress on the section XX. So to know the stress on the section, what I need to do? I need to take the load by area. Yes, the stress is nothing but load by area. So what is load here? Load is P, right? Load applied on either end is P, and the area is A minus Kx times T, right? A minus Kx times T. So now I will concentrate on the strain part. Strain, which I have taken the notation this one. What I can write for the strain? strain I can write for stress by Young's modulus, right? So referred the equation what we have, that is Young's modulus equal to stress by strain, right? So on this part I have written strain, right? Now I will substitute stress and E. So stress in the section is P by A minus Kx times T divided by this E. So if I rewrite this equation, what I can write, P by E times A minus Kx times T, right? This is what the total elongation that is expected at strip, right? I need to consider for this overall length, right? So once I got to know, so what I can get, so total elongation of the bar is obtained by integrating this equation, we can say above equation between the length, or we can say limits 0 to total length L. So now what I can write for on this part, so what I can write on this part is, I will take this equation, just I will differentiate this for understanding purpose. This is the total elongation is taken for 0 to L for P by, I will write ET A minus Kx for dx, right? This is what the equation. So in this equation what I do, I will take this constant term P over, that is P by ET, and I will substitute the limit from 0 to L to 1 by A minus Kx times dx, right? So now what I can do now, I will refer this for 1 by x, right? Integration of 1 by x is log of x, right? So log of x multiplied to the constant with the associated sign, that is what the mathematical part. So that I will include here, and if I include that and write it, so it is P by ET log of to the base E. So here I will write A minus Kx for the length of 0 to L, right? This is what, and multiplying the constant with sign, right? Constant with sign. So now what I do, I will write this to, I will take this minus sign over here to this minus P by E, T and K, right? I have taken this K to this part, right, just for the simplification purpose. Now what it is left between here, so log to the base E A minus log to the base E Kx 0 to L, right? This is what we need to take it down. So now after this I need to substitute the base units, then I will get this. So what I do, I will just take this, so P by ETK log of a to the base e, it is always to the base e, minus log of to the base e, that is a minus kx. Right, so this is what I need to write over here. So this part I will just erase this just to eliminate the confusions. Right, so now this is what the equation is. From the above equation I shall write this one. Alright, so now to this equation what I do, I will just rewrite this or rearrange the terms after substituting from 0 to L. So here P by E T K, right, so which is minus times, if I write, so log, if I substitute this L here, so what I get, I will get A minus KL, right, I will get A minus KL, and again I need to substitute this limit minus log to the base, if I substitute 0 in the place of x, this whole term will become 0 and log a is remained, right, this log a is remained. So now I write this equation once again here, right. So what I have written, P by ETK, this log, I have multiplied this whole equation with minus, so that log a to the base e will become plus, and this log a minus x, right, a minus L will become minus here, this part, right. So I have multiplied this whole equation with negative sign, so that after this I got this equation, right. So once I substituted the terms, so I need not write these limits, right. So after this what I can write, I can just simplify the equation and to write. So here it is like a log a minus log b, right, it looks like log a minus log b. So if log a minus log b can be written as log of a by b, right, this is what the equation. In this form I will write the equation, keeping all the things as it is, right. I will write below this part here, P by E T K, right, to the log to the base e, log a by log b is a minus KL, right. This is what the main equation. Now just substituting k here. So after this we need to substitute only the part of value of k, right. What is k? What we have taken, a minus b by L, substituting back here. So this is total elongation, P by E T a minus b by L log a by a minus b by L times L, right. So now it is just a simplification part. So this is plus a, this is minus a, this L and this L will cancel. So here it is this minus into minus plus b. So what it is remained, so PL by ET a minus b times log to the base a by b. Yes, this is what it is remained. This minus into minus, it is plus b, a by b is remained, log a by b, and this L go to the numerator, PL by ET A minus B log A by B. So this is what the total elongation of rectangular bar under uniaxial load. Thank you.